React server components, the good, the bad, and the ugly. This article was posted a few days ago, and I had a few people tag me on Twitter, X, asking me to share my thoughts on this article and read through it. So I figured I'd do that. I'm obviously biased. I work on Next.js, and I've been talking about server components for a few years now, but I thought it'd be interesting to hear my perspective on the article. I'm going to try to go into it with an open mind and see what we think. So let's dive into it. I'll just read through it and provide some commentary along the way. React server components bring server exclusive capabilities to React. I've been using this new paradigm in Next.js 13 and 14, and what follows is my honest assessment of it. I debated not publishing this post because of the way the React community has historically handled criticism. Well, let's change that. It is only recently that I decided it's important to share my thoughts, especially after seeing that much of the existing criticism is either not well documented or stems from unfamiliarity. I'm writing this from the perspective of someone who cares heavily about user experience. Great. I think that's super important. I also care about developer experience, but the user experience or the user always comes first. I strongly agree, and hopefully we can view this article through that lens of what actually matters to the end user when they're visiting a site built with server components, a site built with the Next.js app router, for example. A quick refresher. I could just get into it, but I wanted to make sure we're all on the same page first, since there's a whole lot of misconceptions about React server components and React itself. Until recently, React could be described as a UI rendering framework that lets you write reusable, composable components as JavaScript functions. These functions simply return some markup and can run on both the server and the client. On the client, the browser, these functions can hydrate the HTML received from the server. This process is where React attaches event handlers on the existing markup and runs initialization logic, letting you hook into any arbitrary JavaScript code for interactivity. Yup. React is often used with a server framework like Next.js, Remix, Express, or Fastify, which control the HTTP request response lifecycle. This framework, or these frameworks, provide a convenient place for managing three important things. Routing, so defining the markup that the URL will have for the path, data fetching, any logic that runs before rendering starts, so reading from the database, API calls, and mutations, so user-initiated actions that happen after the initial load, so form submissions or API endpoints. Fast forward to today, React is now able to take more control over each of these parts. It is no longer just a UI rendering framework. It is also sort of a blueprint for how server frameworks should expose these important server-side features. Yeah, I'd love to dwell on this point for a second here because I think it's really important. React is giving us an architecture. It's giving us, in their words, a blueprint for how frameworks can build on top of these new features and try to take advantage of both the client and the server. And I think that's really powerful. I think we're going to see a lot more frameworks explore this in the future as well too, and I'm excited to see it. These new features were first introduced more than 3 years ago. Yeah, 3 years ago. That's awesome. And are finally released in the Canary version of React, which is considered stable for use within the Next.js app router. I feel like there's some shade there with the quote marks, but I will continue. Next.js being a complete meta framework, drop meta, it's just framework. Next.js being a complete framework also includes additional features like bundling, middleware, static generation, and more. In the future, more frameworks will incorporate these new features, but it will take some time because it requires integration at the bundler level. Yeah, this is, I think, a key thing of understanding server components as well too, is that it does involve bundlers, and the official example that the React team has using Webpack, for example, just shows like a really basic server component setup using their Webpack configuration. So definitely requires bundler involvement. React's older features have been renamed to client components. I feel like, I don't know if I would say renamed. That to me, that almost feels like more of an ecosystem shift than what it actually is, because everything was a client component up until a server component. But framing it as older to me just feels like they're of less value, but they're of equal value. Both client and components are both part of the model, and they're both good. They can be used alongside server features by adding the use client directive at the server client boundary. Yes, this name is a bit confusing, and these client components can add client-side interactivity and also still be pre-rendered on the server, same as before. Yes, the pre-rendering bit, I agree, is definitely a bit confusing. I have another video on my channel where I talk a little bit about client components and kind of talk through the myth of, are client components bad? They're not bad, and since they're still pre-rendered on the server, you can think of this for the Next.js folks as basically exactly how the pages router worked before. Okay, all caught up. Let's dive in. The good. First of all, this is cool. Yeah, it's very cool. Server-side data fetching and UI rendering in the same place is hella nice, as they say. Hella nice. But this is not necessarily a new thing. The exact same code has worked in React via Fresh since 2022. I mean, yeah, server-side templating isn't necessarily a new thing. I think we've had server-side templating frameworks and solutions for a really long time. I think it's new to the React ecosystem. I guess Preact is an extension of the React ecosystem, but I think that comes with other trade-offs as well too. I think that I'm excited for it because of the mix between the client and server, not just the fact that I can mark my components as async, but the entire model and how it integrates. And I'm sure we're going to get into that a little bit more here. Even within old school React, it has always been possible to fetch data on the server and render some UI using that data, all as part of the same request. Yes. Code below is simplified for brevity. You'll usually want to use your framework's designated data approach. Let me scroll down a little bit here, like Remix or Astro or the Next.js pages router, same way. Within Next.js specifically, this used to be only possible at the route level, which is fine and even preferable in most cases. I think that is possibly maybe too opinionated. I think that it is preferable in some cases, but it highly depends. I think there are advantages to being able to fetch data close to the UI that renders the data, especially when we get into talking about composability, which I believe that they get into. But this is a preference, and this is something that can still be enforced. For example, you could still use the app router basically in the same type of data fetching architecture as the pages router, where you have a top level data fetcher, data loader, whatever you want to call it. So I don't know if it's most cases. I think that we can talk a little bit more about partial pre-rendering and how we're trying to think about that going forward a little bit as well too, but it depends. Whereas now, React components can fetch their own data independently. This new component level data fetching capability does enable additional composability, yes, but I don't care for it, okay? Nor does the end user when they visit your page. That I agree with. I don't think it is necessarily a UX benefit to have the composability, unless you're thinking like, because my team can move faster, therefore we're able to build a better product and thus we're delivering more end user value. It's probably a stretch. It's probably a bit much, but it is a great DX benefit. But going back to the framing from the beginning of the post, this is really about UX, so agreed. If you really think about it, the idea of server-only components itself is pretty straightforward to achieve. You render the HTML only on the server and never hydrate it on the client. That's the whole premise behind Islands architecture, frameworks like Astro and Fresh, where everything is a server component by default and only the interactive bits get hydrated. I think the framing here of like server-only components are straightforward to achieve. The thing that I am trying to pull apart in this message is it sounds like that is like a trivial thing. Like, oh yeah, like this isn't that hard to do. I don't think the fact of just being able to fetch data on the server is the only thing. I think I'm probably going to beat a dead horse here, but I think it's how the entire model works together, but we'll see. The biggest difference with React server components is what happens underneath. Okay, I probably should have just read the next paragraph. Server components are converted into an intermediate serializable format, which can be pre-rendered into HTML, same as before, and can also be sent over the wire for rendering on the client. This is new. But wait, isn't HTML serializable? Why not just send that over the wire? Yes, of course, that's what we've been doing all along, but this additional step opens up some new interesting possibilities. Server components can be passed around as props to client components. So if you have a server component at the top of your tree, and then somewhere in the middle, you can have a bunch of client components, but you can pass and you can weave these together where the child of a client component could still be a server component, and so on and so forth. So that's really powerful. React can revalidate the server HTML without losing client state. Also huge. I think this is super underrated benefit of this, especially as we get into talking about server actions and mutations. In a way, this is like the opposite of the islands architecture, where the static HTML parts can be thought of as server islands in a sea of mostly interactive components. Slightly contrived example. You want to display a timestamp that you format using some fancy library. With server components, you can format this timestamp on the server without bloating your client bundle with this fancy library. Sometime later, revalidate this timestamp on the server and let React re-render the displayed string entirely on the client. Previously, to achieve a similar result, you would have had to enter HTML, a server-generated string, which is not always feasible or advisable, so certainly an improvement. Instead of treating the server as simply a place to retrieve data from, you now retrieve the entire component tree from the server, the initial load and updates. It's more efficient and results in a better UX. Sure. With server actions, React now has an official RPC-like way of executing server-side code in response to user interactions, mutations, and it progressively enhances the built-in HTML form element so that it works without JavaScript. Cool. Code example, we're going to gloss over the fact that React is overloading the built-in action attribute and changing the default method from get to post. I don't like it, but whatever. Well, I think this is more of a DX thing than a UX thing, but yes. We're also going to gloss over the weirdly named use server directive, which is needed even if the action is already defined in a server component. It would be more apt to name it something like use endpoint, since it's basically syntactic sugar for an API endpoint. But again, whatever, I don't care, even if it's called use potato. So the key thing here of why the use server directive needs to be included is it's really, and I'm sure they know this and they probably just don't have it explicitly listed out here, but for the viewer, that's how the bundler is able to understand, or the compiler is able to understand this thing, this little bit of code that I'm writing, this function. This is what gets turned into my hidden API route, basically. And I personally don't think it's a bad thing to have to be explicit about that, even if I'm in the context of a server component, especially because even if I move this out into a separate file, which in general, I think will probably happen more of the time, is you'll have separate files for your actions versus, and kind of having like this data layer in your application versus inlining them in the file. And when you do that, you mark the file with use server at the top, and then all of the exports in that file are going to be your server action. So I think that's more common. But again, this is kind of like a bike shedding naming thing. The example above is almost perfect. Everything is co-located, feels elegant, works without JavaScript. So the framing here, I think, from the user perspective is that it's not even that it works without JavaScript, it's that it progressively enhances, because when you probably don't have no internet or no JavaScript, you probably have slow internet or spotty internet, and your JavaScript hasn't loaded yet. And we still want our applications to work in those instances. And that's like the UX framing here that I think this nails really well. Even if most of the business logic lives in a separate place, the co-location is especially nice because the form data object relies on the names of the form fields. Most importantly, it avoids the need to wire up these pieces manually, which would involve some gross spaghetti of making a fetch request to an endpoint and handling its response, relying on third-party libraries. In a previous draft, I wrote all this under the good because it's legitimately good. However, it starts to get annoying when you want to handle more advanced cases. So just to talk about this point one more bit, I do think it is really, really nice that you don't have to manually wire up the fetches from your components to an API route just to do that data mutation. Not only is it less code, it just helps me move faster when I'm actually building applications. Now that I've written code in this server actions model integrated with server components as well too, it's kind of hard to go back. Like, writing code this way feels so much better than the previous model, but I'm obviously super biased, so I will let y'all make that decision yourself. Okay, let's get into the bad. This is where I guess it will get spicy. We'll see how it goes. Let's say you want to progressively enhance your form so that when the server action is processing, you prevent accidental resubmissions by disabling the button. You'll need to move the button into a different file because it uses use form status, a client hook. Mildly annoying, but at least the rest of the form is still unchanged. So I don't know if this sounds like more of like a DX thing that they're caring about right now instead of a UX thing. Like, they want, one of their needs is that all of the things are co-located, which I think is fine in some cases, but I think there are also reasons to have separation between server and client components, a separation between server actions and those server client boundaries. So it also kind of feels, again, like it feels like that could be framed as a negative of having a client component. I don't personally think it's a negative. Like, okay, we want to tap into this client hook of use form status, so I have this componentized submit button. I think that's fine. Let's say you want to handle errors. Most forms need at least some basic error handling, which, by the way, before we go any further, you could just use HTML validation for this as well too, or server-side validation in your server action. That will get you at least some basic handling, but I kind of agree with the premise here, which is like you probably want to provide some feedback to the user based on when something goes wrong outside of just the browser defaults. In this example, you might want to show an error if the email is invalid. So, I mean, you can use type email. That's going to get you a little bit, but it's not going to get you fully there. To use the error value returned by the server action, you'll need to bring in use form state, another client hook, which means the form needs to be moved to a client component and the action needs to be moved to a separate file. Yes, but also you could still weave the server and client components here as well too. So the top part of the form, yes, does need to be using a client component so that it can use form state, correct? I do agree, this is like a little confusing that it does still work without JavaScript and progressive enhancement is supported, because like the first mental model is like, oh, like client component, would that still work with progressive enhancement? But yeah, it still does. So, which is awesome, which is great, but I can understand how that could be confusing. The closely related code is no longer co-located. Yeah, I mean, this is like a DX thing. I mean, I personally don't think it's that big of a deal, but I could see how that could be annoying for some. The action needs to use server directive, so why not allow defining it in the same file as the client component? I think that could get a little messy. The action signature has suddenly changed. So what they're referencing is with use form state, I import, for the some action here, save email action, and then I get back the form action and I pass it into my form. Then save email action here, the signature is different. Not only do we add the form data, but we also have some additional data that we can bind or we can pass along. Why not keep the form data as the first argument? I'm sure someone much smarter than me has convincing arguments for this, but I trust the design of the API. I think seeing the bind pattern, which I think is outlined in the docs, does make sense after seeing it now in practice here. And again, this is like bike shedding around DX stuff. At the end of the day, the fact that the progressive enhancement still works is really what matters from the user's perspective. It took me a little bit of fiddling to make this work without JavaScript because the documentation, which has changed several times recently. So the React documentation shows a broken example. First off, well, I don't think it's necessarily bad that documentation changes. I think that should be celebrated. Like, we want to update documentation. But yeah, broken examples aren't good. I'm guessing this is probably fixed now since the last time I looked at this, but I can double check and make a PR if not. The key insight here is to pass the server action directly into use form state and to pass its return action directly to the form's action prop. If you create wrapper functions, it will no longer work without JavaScript. I don't know if this is accurate. I would need to verify that, but I don't know if that's accurate. The use client thing directive also starts to get unwieldy as your application grows more complex. It's possible to interleave server and client components, but it requires you to pass server components as props rather than importing them as client components. This might be manageable for the first few levels from the top, but in practice, you will rely mostly on client components when deeper into the tree. That's just the natural and convenient way of writing code, which is fine. I mean, I don't think it's necessarily, again, a problem to use client components. Let's revisit that timestamp example from above. What if you want to display a timestamp within a table, which happens to be a client component, nested within multiple levels of other client components? You could try to do some prompt drilling and store it in a server component, in a global store, or context at the nearest server client boundary. Realistically, though, you might just keep using client components and send that file, like date functions, to the browser. Yeah, I think like this, again, using a client component is fine. It's not always going to work to be able to optimize your entire application to use server components. We have to view this from the lens of what was the model like before, and then what is new to the model. So the model before, everything was client components. There was no additional optimization levers that you had to shift more of that bundle from client to server. So there will always, until the end of time here, be instances where you'll be using client components, and that's fine. It is good though, and I think it's nice that you have the option to optionally optimize some bits to server components as well too. Being locked out of async components after a certain depth might not be such a bad thing. You can still reasonably build your application, since data fetching should probably only happen at or near the route level. This was, again, like the opinion thing from above, debatable. A similar limitation also exists in islands frameworks, and that they do not allow importing static server components within islands. It's still disappointing though, because React took 3+ years and came up with the most complex solution, all while promising that server and client components will interop seamlessly. I mean, I can't speak to what we define as complex or not complex, because I think that what's tricky is that for a lot of people, especially the author of this post, people who've been in the ecosystem for a while, sometimes things feel really complex because of all of the previous knowledge that we have. Like, this author clearly has a lot of knowledge of how React works, how the ecosystem works. That actually might make it harder to learn this model than somebody who's learning this from day one and has no background knowledge of how any of this stuff should work, which I think is really interesting. My understanding is that with larger multi-year long architecture designs like this, there's, not maybe even more emphasis put on the new developer who's learning this from the first time than necessarily bringing along the existing folks who have a lot of, prior knowledge and context, because they're going to figure it out. But I don't know. I don't design frameworks, right? I just help teach people about them. What may not be obvious is that this restriction has some serious implications. Inside a client component, all of its dependencies and its dependencies, and so on are a part of the client. This cascades down pretty quickly. Yeah, I think what they're referencing here is that it is not required that you mark every single client component with use client. So the child of a client component will be a client component. Only the top component there would need to mark it with the use client directive. And it says a large number of components do not use features exclusive to the server or the client. They should probably stay on the server, but they will end up in the client bundle because they were imported by other client components. You might not even realize this if the components do not use client directive themselves. To keep the code small, you'll have to be intentional and stay vigilant, because doing the wrong thing is easier. It's like climbing out of a pit of failure. I think the real solve here, what would really make this easier, and what I think has to happen for the ecosystem, is just better dev tools so you can visualize your tree and your server and client graphs. I think that's really the real solve here. You could have lint rules around ensuring that you always use client directives to all files that need them, but I think that's probably not the right solution. Okay, where's getting started? The ugly. For some godforsaken reason, Next.js decided it would be a good idea. Well, hold on. We just went from React to Next.js, so I guess now this is a Next.js post. But fair, right? We're the first place to implement all this stuff. Next.js decided that it would be a good idea to extend the built-in fetch API within server components. They could have exposed a wrapper function, but that would have made too much sense, I guess. And by extend, I don't mean adding additional options to it. They've literally changed how fetch works. All requests are aggressively cached by default, except if you're accessing cookies, which then it might not be cached. So a couple things here. One is that we are changing away from the extension of adding additional options to fetch. Part of this is part of how partial pre-rendering will work. So rather than passing in like this special next option into fetch where you can define your revalidation times or, passing in the caching options into fetch, you will have functions like no store, which we already have available right now. It's just not fully stable yet, that allow you to opt out and have dynamic rendering. And there will also be ISR-like functions in that same format. So rather than putting the time value as an argument for how long you want to revalidate after or how you tag your cache, you'll have functions to do that as well too. But the deduping part isn't planned to go away for now. And the part about accessing cookies, if you access cookies, you're going to opt. This is a little confusing, and I think there's a lot of work to still do around educating people on the patterns here because it's new. But if you access cookies, that's a dynamic function, just like reading from headers. You're reading from the requests. So you are now dynamically rendering. And when you dynamically rendering, you can still have cached data, which is, I think, breaks the brain of the previous model a little bit because it was either all or nothing. Either you had the entire route cached or none of the route cached. Either you had your cache control headers for your page or nothing. What this model is doing is it's breaking down caching to the data level, and you can have a dynamically rendered component which has some data that's cached and some data that's not cached, which I agree. It's a lot. It's going to take some time to explain this, and that's my job. I'm going to hopefully try to make this easier and make more examples and teach people about this. You might not even realize what is and isn't cached until you deploy to production because the local dev server behaves differently. This is likely a bug. I would be curious to see what they are looking at because ideally the behavior of next dev should be the same behavior of next start. So please let me know. To make matters work, Next.js doesn't let you access the request object. I don't even have the words to articulate how ridiculous it is that they would hide this from you. So this is definitely a common question. It's a common thing that you might expect because coming from the pages router world, coming from the get server-side props world, you would take in a request and you would produce a response that could have some caching headers. You could forward some JSON from your data fetching function or your loader to the page. The big difference here is that one of the key design constraints of the app router, of this entire model really, is based around streaming. And streaming can really help improve the user experience of the page. But with streaming, and specifically in the context of rendering server components, the other thing we have to consider here is that you want to be able to have layouts that can maintain state across transitions, and you want to be able to look at your application and understand how are my layouts and how are my pages affecting what is going to be maintained across those transitions and what isn't going to be maintained across those transitions. And I think that, for example, if you give access to the underlying request in a completely raw way where you can do whatever you want with it, it just makes it a little bit harder from the framework design to be able to control falling into quote unquote the pit of success of how the framework is designed to be, which is why to access the request, you're accessing headers and cookies and functions like that. I will say that it is possible that some of this could change, but at least for right now, I think that from what I've seen when I talk to people in the community, when they say their initial feeling is, why can't I access the request object? And then we talk through what the actual product or user use case is. And then it's like, oh, okay, I see how I can do that through accessing cookies, through accessing headers, through accessing the params or path name from the page, or on a client component, accessing search params or path name as well through there too. So it depends. You also can't set headers, cookies, status codes, redirect outside of middleware. So you can set some of these things in server actions as well as route handlers too. So it's not just middleware. This is because the app router is built around streaming. Yes, it would be too late to modify the response after streaming starts, correct? But then why not allow more control over when streaming starts? I feel like that's probably not an easy thing to design or impossible thing to design for the framework. But again, that's something maybe I need to learn more about, and I can talk to the team and try to get more context on that. But I'm guessing that option was considered. Middleware can only run using the Edge runtime, which makes it too limiting for many scenarios. Yeah, I think this is also an open request from the community, being able to use all of the Node.js API methods there. Side note, that still works even if you deploy on a Node.js server. It just has the subset of the APIs. That's something that we're still exploring and considering. In that instance, you can also, for example, let's say you were wanting to do some kind of auth check. You could do that in a layout where that layout is over a group of pages that you want to have the auth check. If the auth check fails, then redirect. But yeah, I can see how that gets tricky then if your auth check required looking at the incoming request, which middleware does have. In the old Next.js pages router, none of these problems existed. Routes behaved predictably, and there was a clear distinction between static and dynamic. This is interesting because it's an interesting framing. None of the problems existed, but also none of the potential benefits existed. Like server components, server actions, this integrated model for fetching, caching, and revalidating data, which can have dramatic impacts on the user experience. It wasn't an option. And I actually have a whole conference talk about the pages router model and some of the customer-focused, user-focused pains that you would see when trying to build things with that model. It's linked on my channel. So yeah, like none of the problems existed, but you didn't also give you the opportunity to have some of the upside as well either. You have to go into this assuming that, there's a reason that these things were built to solve problems that, maybe they don't match for you, but my guess is that it's largely an enablement or an education problem for me to help bridge the gap between why these things exist and how they solve those problems. Routes behave predictably, and there was a clear distinction between static and dynamic data. I do think that this is the toughest one. The model of either my whole page was static or my whole page was dynamic, it is definitely conceptually easier to understand. Like hands down, 100%, totally agreed. And you can still model your application in that way. I understand that with the app router model, it's kind of inviting you to not do it that way. But we do think there's a lot of value and benefit in doing it that way. I think the challenge is just on education and tooling and dev tools to help make that a little bit more easy. You had access to the request information. You can modify the response, which, by the way, there are still ways to read the web request and produce a web response with middleware and route handlers. So it's not to say that you can't do that anywhere. It's just, I think, within the context of server component rendering. You had more control. That's not to say pages router didn't come with its own weirdness, but it worked fine. I also think it's worth mentioning, pages router still exists. We're still investing there. Next.dev-s turbo, aka turbo pack inside of Next.js. Like that all works with the pages router too. Like we want to make that experience really great as well. And if it's working great for you, yeah, keep using it. Oh, the uglier. I thought it was already ugly. Why you got to get uglier? Everything I've mentioned so far would have been tolerable to varying degrees if the bundle size got smaller. In reality, bundles are getting larger. I think that's an interesting thing to highlight because I don't think the user actually cares about bundle size. I think they care about the experience. And if your framework helps you get a better user experience, I don't think it necessarily matters if the bundle is a little bit larger, but for example, more of your page could be cached or the initial paint was faster, for example. So feels like it's kind of contradicting the initial framing of this article around focusing through what the user cares about. 2 years ago, Next 12 had a baseline bundle size of 70 kilobytes compressed. Today, App Router with a baseline of 85 to 90. After uncompressing, that's 300 kilobytes of JavaScript to the browser needs to parse and execute just to hydrate a hello world page. To reiterate, this is a minimum cost that users need to pay, regardless of the size of your website. Concurrent features and selective hydration can help prioritize user events, yes, but do not help with the baseline cost. Agreed. They're probably even contributing this cost too, just by virtue of existing. I mean, yeah. Yes. To have features, you have to include React so that you can use the features. So yes, it does. By them existing, it does increase the size. You kind of have to look at it through this lens. Does adding the new features, does having this higher baseline for the time being, does that help produce a better user experience? I think the answer is yes. And I think the field data does, the crux data does show that, but I'll let y'all be the deciders of that. Caching can help avoid the cost of re-downloading in some cases, but the browser still needs to parse and execute all that code. If this does not sound like a big deal, consider that JavaScript can and does fail in many ways. So why does this matter? Because reducing bundle size is touted as one of the main motivators for React Server components. I don't know. I mean, yeah, it was mentioned in the RFC, it was mentioned in the blog post, but I don't think that that's like the only reason it was made. I mean, maybe they correct me if I'm wrong. I'm not on the React team, but I don't think it was just about reducing bundle size. I think that there's two things to consider here. One, like, yes, I would still like to make the base time, the base JavaScript that's included smaller. But I think the problem that's being solved is more about the day 1,000 experience. How do we make it such that when we add the 100th, the 500th, the 1,000th component, that you have the ability to not let every single incremental component add up and bloat the client bundle size? That's like the main JavaScript bundle size problem that server components are solving, not necessarily just the baseline. I think there's still an opportunity to make the baseline better, but solving that other problem, I think, is much harder and also much more impactful as well too, because most of these apps aren't hello world apps on day one as well. Sure, server components themselves will not add any more JavaScript to the client bundle, but the base bundle is still there, and the base bundle now also needs to include code to handle server components fit into client components. Then there's also the data duplication problem. Remember, server components don't render directly to HTML. They're first converted into an intermediate representation of the HTML called the RSC payload. So even though they will be pre-rendered on the server and sent as HTML, the intermediate payload will also be sent alongside. In practice, this means the entirety of your HTML will be duplicated at the end of the page inside script tags. The larger the page, the larger these script tags. All your Tailwind classes, oh yeah, they're duplicated. Server components may not add more code to the client bundle, but they will continue to add to this payload. This does not come for free. The user's device will need to download this document, which is less of a problem with compression and streaming, but still consume more memory. I'll pause on this bit because I think it's helpful to consider how the model works today and what the motivation for including this was. I think that sending data as part of the page and then using that data to hydrate the page is how the Next.js pages router worked. It's how, many other frameworks work, including things like Quick. And we have to kind of work backwards from what the ideal experience we want is. So the app router model, as we talked about a little bit earlier, it's built upon streaming. So if we took that same approach and we applied it to the streaming world, we would effectively be blocking the first initial paint by putting that early in the stream. And we obviously don't want to do that. So when you think about this app router first world, the streaming first world, we're trying to optimize the user experience. And the trade-off that they've made is by putting that data at the end of the stream. And, I'm sure they've considered a bunch of different ways on how to do this. Again, I'm not the framework designer, but it seems like the trade-off that they've been making is not necessarily about, counting the specific bytes. I'm sure there were other ways they could do it where those bytes were in a fetch versus being streamed in at the end. But the design that they've taken allows for you to get a fast initial paint by content being streamed in. That content that's streamed in can also still be able to be, like forms, for example, you can still support progressive enhancement by clicking on buttons, triggering forms, calling your server actions. So you're getting something to the user very quickly. And then you're also streaming in parallel the rest of that JavaScript and that additional duplicated data at the end of the page, or the RSC payload, that is streamed towards the end. So my read on this, not an expert, but my read on this is that it feels like a good trade-off for the UX that they're trying to get. And there's probably other optimizations that they can still make here. I think the official spec of the RSC payload, I think, is evolving as, the team gets feedback from the Next.js team and others who are exploring using server components. So I think there's still ways that things can be optimized here as well too. But if we really focus on the end user experience, I think streaming is absolutely the key unlock here. But then how we do the streaming, I think, impacts everything here. And that's probably why the RSC payload has been designed in this way. And I think as well too, getting into this last paragraph, it's how the whole model is designed. So I'll read through this and then we'll talk about that. Apparently this payload helps speed up client navigations, but I'm not convinced that's a strong enough reason. Many other frameworks have implemented the same thing with only HTML. And more importantly, I disagree with the very premise of client-side navigation. I feel like that's a strange take because client-side navigation can give a fantastic user experience. And going back to the framing of this article, that's what we're here for, right? The vast majority of navigation on the web should be done using regular ass links, which work more reliably and don't throw away browser optimizations. I think Next.js still integrates with BF Cache. Don't cause accessibility issues. That's probably a bug. And can perform just as well with prefetching. Using client-side navigation is a decision that should be thoughtfully made on a per-link basis, which you can do in Next.js, by the way. Building a whole paradigm around client-side navigations, it just feels wrong. I don't know about that. First off, I think the paradigm is around the way the server and the client work together. I think the paradigm is around being able to update your UI in place. So you do some mutation with a server action, you fetch back both new UI and the new data for that mutation. That's the paradigm. Being able to have a really fine-grained cache and be able to cache bits of data and easily programmatically revalidate that data and navigate between different pages and have parts of your layout retain state. That's the paradigm. And I think that's really powerful from creating the user experience that users will love. I think getting into a developer battle around whether we like client-side navigation and how it's implemented or not probably isn't the right framing for what's the most important here. But I agree that I think it's still healthy to have these types of discussions because ultimately they can help push the web forward, they can help push framework design forward. But hopefully that framing at least helps you consider, if you're looking at it through the user experience lens, what's the best way to design a streaming first solution that integrates all of these pieces into the paradigm. And yeah, closing thoughts. React is introducing some much needed server primitives into the world, Many of these capabilities are not necessarily new, but there's now a shared language and an idiomatic way of doing things, which is net positive. I'm cautiously optimistic about the new APIs, warts and all. I'm glad to see React embracing a server-first mentality. At the same time, React has done nothing besides an abandoned experiment in 2019 to improve the pitiful client-side story. That's a bit harsh. I think that even though these features are designed for server and client integration, there's also a not yet well-explained story around how you can use these things to make the client experience better as too. Like that was heavily considered as part of the model. Like for example, when you go look at some of the demos of actions, so form actions and use form state and use form status, like the demos that the team has in Code Sandbox, like these aren't Next.js apps. They're not using the server. They can work in the client. I think that's awesome. I think there's a whole story still to be told there. It's a legacy framework created to solve Facebook scale problems, and as such is a bad fit for most cases. Heading into 2024, here are some of the things that React has yet to address. Yeah, it's interesting because this feels like a laundry list of like DX things that I don't think really matter in the large picture. Also, like some of the stuff will probably change soon. I'm guessing there will be new versions of React that if there's this synthetic event system that's unnecessary, or if they have things that they want to remove in the future, like maybe that'll happen. Maybe I know that there's already been some discussion around some APIs that maybe don't need to exist anymore in the future or will be deprecated. So I'm confident things will continue to improve and iterate. React has never been the first to move, but they always move very thoughtfully. And with that, I have a lot of respect for. So yeah, I don't know. Yeah, use effect's complicated. We could all agree that use effect is difficult. Hey, that's why this new model is super helpful. You write less use effects, only when you actually need to write the use effects. These aren't unsolved problems, they're invented problems. Yeah, it's a bit harsh. In a world full of modern frameworks, Svelte, Solid, Preact, Quick View, Marco, React is effectively tech debt. Again, I feel like kind of harsh. I'd argue that adding server capabilities to React is much less important than fixing its many existing issues. I think there's like a balance of both here. I don't think that they're, at least my read on it is, I don't think they're just not fixing existing issues. I think this is like a multi-year effort into fixing issues especially from a UX user-focused perspective. Like, how do I make it so that the page is interactive before the JavaScript is hydrated? Like, that's like a multi-year effort and lots of APIs that have been released to solve that user-focused problem that I think has landed with like a pretty elegant solution. It took some time to get there, and ultimately I feel happy with the end result of where it's at right now. Maybe you're not convinced about any of the problems, and maybe you call it sunk costs and go on with your day. I mean, sunk cost fallacy is a real thing, especially for people who have like spent their whole career working on React applications. Like, you have to call that out. Like, if you are building with React, you have so much context, and being a React engineer, hopefully that's helped you also become a better UI developer, a better UI engineer, a better developer of the web. But you have that knowledge that you've built up as a React developer. We can't ignore that, but I don't think it has to be a sunk cost. I know that my investment into React has helped me become a better engineer, like full stop. Just understand how to build better products, all up. Yeah, Next.js has a long way to go. Still new, 100%. I do understand these open source projects are not obliged to solve anyone else's problems, but React and Next.js are both built by 4 huge companies, something they both use in their marketing. So I think criticism is warranted. I don't mind criticism. I think that constructive criticism, especially in this format, which I super appreciate, like, this person clearly has a ton of knowledge of this subject and took the time out of their day to write this, which I have so much appreciation for. So I think it's good. I think this is constructive. I think this type of video and this type of discussion, me rambling for who knows how long I've been rambling, is hopefully helpful as well too for people. Final note, I just want to emphasize it's difficult to draw a line between React and Next. Some of these new APIs might look different within a framework that has more respect for standards. This is like, I don't know if they're trolling me at this point. I don't know if you haven't seen it. I have a blog post on my blog, leerob.io/blog, where I talked a little bit about this. Like, the Next.js app router is using web standard APIs. For example, middleware, route handlers. You read in a web standard request, you produce a web standard response. The headers and cookies APIs, those are built on web APIs. Like, the foundation is web APIs here. So the whole standards thing is like, it's a little bit much, I think, personally. I think that Remix does lots of things great, and they've certainly pushed forward the React community's appreciation for using web APIs and using, quote unquote, the platform. But I think sometimes this framing hasn't considered all of the APIs inside of Next.js. Definitely not the app router world, but I'll give this author the benefit of the doubt. I'll be sure to post an update when that happens and some footnotes. Okay, well, that was long. Hopefully interesting, hopefully educational to see my, of course, biased perspective on all of this. I'd love to hear what you think. Leave comments down below. Did I miss anything? Was I completely off on a certain point? Make a response video back to me as well, too. I'd love to hear that as well. But that's all for today. Peace.